Jai Hind. My name is Vivek Agarwal. I'm the assistant professor in the Department of Computer Science and Engineering of Ajay Kumar Engineering College. So today we are going to have a lecture on the topic regression modeling and the Bayesian modeling. It is the part of the course curriculum of the Unit 2 of this Introduction to Data Analytics and the Visualization. The code is BCDS 501. So as we already gone through in the first unit, what is the data analytics and what is the visualization and how they are important, what are their application domains and what are their various applications. In day-to-day life, we can have the applications of the data analytics and the visualization. Now in the second unit, we are more focused about what are the various models and what are the various techniques through which we can perform these analytics. So for having the different kind of the data or the different kind of the application or different kind of the uses, we can have the different kind of the techniques to make the data analytics things. So out of them, the regression modeling is quite very popular, and one of the regression and the Bayesian modeling is very popular and widely used by the various various techniques and various tools, and various tools uses the same technique and the modeling for making some analytics. So start with the regression modeling. So it is a statistical model. If I need to differentiate the regression and the Bayesian is a probabilistic model which works on the probability, and the regression is typically a statistical model which works on a mathematical function, or I must say the mathematical calculation. So regression modeling is a statistical technique that analyze the relationship between the dependent variable and one or more the independent variable to understand how the changes in the independent variable influence the dependent variable. Means in any data set or in any data to which we are going to analyze, there could be a number of variables. Out of them, we need to figure it out something outcome. So for example, if any sales, if I talk about any sales data, there may be the consumer, maybe the consumer age could be a factor, maybe the consumer location could be the factor, maybe the customer segmentation could be the factor, customer the currency may be a factor. So there could be multiple factor, maybe the age, maybe the caste, maybe the location, maybe the weather, maybe the some festivals criteria or not, like. So on that basis, we can have an analysis on the outcome. Means are we going to have some analytics on the outcome of the sales data, maybe in terms of the influence on the sales of a particular product, or maybe the overall growth in the sales revenue. So there could be a number of multiple factors, maybe a single factor, maybe a multiple factors which are resulting into something, an outcome factor. So just to identify this, how this is dependent on these independent variables, the kind of the relationship can be plotted, can be analyzed, or can be figured out using some regression modeling. So if we had a relationship figured out between these, some like this is your outcome and this is your input variables, right? So if we are able to draw some relationship between them using a some curve, so which is can be called as the regression modeling. So on the basis of the characteristics of this curve, we can have the multiple type of regression we are going to have in the second slide. So it establish a mathematical function. Likewise, if we are seeing this as a graphically, we can have in the form of some curve, but we can plot a mathematical function. Suppose this is y and this is x, so we can have y of something x. Suppose this is your a naught, means we are having some coefficient with the a naught, we can have we can derive this y. Suppose this y is not necessarily to be starting from the point 0, so we can have another point like b naught plus a naught x. So such kind of a mathematical function can be established between these, the input variables and the output variables. Suppose I just imagine this is the y outcome and these are the x's, maybe single or maybe the multiple x's. So common type include the simple linear regression, where we are having the one independent variable, multiple linear regression where we are having the multiple independent variables, and polynomial regression for non-linear. As I said, the characteristics of this curve depends. So purpose of the regression modeling is for prediction, widely used for the prediction, and generally in the regression we have a concurrent, I must say, a value. A value as an outcome, not the classification. In generally regression, we do have some outcome like what, like if I would need to calculate, or I need to predict what could be the temperature of tomorrow based on the temperature conditions and some other factors of the last previous few days. So I can calculate, or I can predict the what could be the what could be the temperature of the coming next day, maybe the coming 2 days, coming 3 days, coming a week, a month. So that value must be in figures, like it could be 24 degrees centigrade, 24 degrees centigrade. So we are, as an outcome, we are going to obtain a figure. But in classification problems, we do have some classes, predefined classes. We can classify the prediction in form of like this could be hot, this could be cold, or this could be a pleasant weather. But in the case of regression, generally we do get a value. So for the prediction things, we can have the regression modeling for understanding the relationship as well. Like as I said, there could be some dependent variable and the independent variable x and y. So we can have a good idea about the relationship, how they are being related to each other. If I talk about the application areas, then forecasting, where we can predict the sales, stock prices, or other financial outcomes we can have. And the risk assessment, identifying the risk factor of the disease or evaluating the investment, we can have some risk assessment using the regression modeling. Product development, influence product decision by understanding the key drives of the success. Like if you are going to you are planning to launch a product, but you are not sure whether this product would be a successful in the market or not. So you can have a regression model for just to have analysis on the user's choice and user's preferences. So on that basis, you can have a good idea about the product development, what kind of the things or what kind of the feature can be embedded in that product. And another could be the social sciences, examine the impact of factors like income or happiness or crime rates. Sometimes sentiment analysis as well can be the application area of the regression modeling. Key component, if we do talk about the a practical setup, experimental setup for having the regression modeling. So there are some key factors, that is independent variables. Like I said, all the variables or all the factors which are going to influence the outcome or my predicted prediction class or the predicting variable. These are the independent variables. Suppose if I need to if I need to have a calculation or the prediction on the what could be the temperature of tomorrow, or maybe the after 7 days. So it could be dependent on various factors, maybe the temperature of last few days, maybe the current wind scenario, maybe the some other geographical factors. So all these factors could be called as the independent variable for getting the outcome of what could be the temperature. And the dependent variable actually to which we are going to analyze, or I must say as an outcome, we are going to regression on that variable. We are going to predict that variable. So that variable can be called as the dependent variable. Regression line, the representation of the relationship between the dependent and the independent variable is called as the regression line. And the parameter or the coefficient, as I noted there in the previous slide, A naught and B naught, there may be some coefficient because there if I say y is equal to x, means that is typically similar to that, but how that is differ or how that influenced with the x, y, so there must be any coefficient like A naught could be there, the coefficient through which we are having a relationship between x and y. And there may be some other coefficient as well, which can be defining that relationship in a right way. And the last is error term. If we are going to make a model, a mathematical model on the basis of the inputs, there could be, and on that basis we are going to predict some new elements or the new values. So there could be some minor error things or minor errors that can be represented as the error terms. We can generally denoted them using something u or and different notations in different scenarios. Represent the unexplained variation in the dependent variable that the model does not captures. Type of regression, as I said in the previous slide as well, there could be a simple linear regression or maybe the multiple linear regression. If I do categorize in a broad category, there could be the regression of the linear regression or maybe the non-linear regression. Simply as the name suggests, if we are talking about the linear, means the relationship would be the linear way. We can have a straight line, but in the case of non-linear, the relationship may be in the form of any curve, maybe like this or maybe of any other shape, will depend on the relationship. So a straight line is a linear regression, a curve is non-linear relationship. And if we talk about the simple linear regression, the possible two types of linear regression. Simple linear regression, where we are having only one variable, one independent variable for dependent variable, means as I said, x and y is the outcome or the dependent variable and the x are the independent variable, single or maybe the multiple. If this x is only one, then this could be called as a simple linear regression. If this x is containing multiple x's or multiple part, means like x1, x2, x3 up to xn, then that could be the case of multiple linear regression. That also called as the multivariate linear regression or multivariate analysis sometimes, when we are dealing with the multiple input variables or multiple independent variables on which we are going to regress or on which we are going to predict the outcome of the y. So typically, as I said, in the linear regression, the regression line or the relationship is typically a straight line. It may be in any direction, maybe in this direction, maybe like this, maybe like this, maybe like this, maybe like this. So the line could be on any axis or maybe, and I can call it like, it may be like this, maybe like this. So in a single example, in a single scenario, also we can have a multiple lines. Suppose there are some data points which are available with me. Data points means, so whenever I have a data set which is having multiple rows, each row can represent a data point. So each data point can be plotted in some dimensional space, right? When we are having the data points plotted in my dimensional space, and I need to make a relationship line between them. So there could be multiple lines that will vary on the basis of these factors, like this, the A naught, B naught, and or simply I can call it A, B, and C, where A is denoting the relationship between x and y, or I must say the slope. If we are talking about the line, we can have it like a slope. The functional coefficient for representing the slope, B could be the additional adjustment in your regression, and C is your error term. So on the basis of this A, B, C, we can have a multiple lines in the same diagram or in the same scenario. So what line must be chosen by us as in the final regression line? So that is called the best fit line. And for selecting the best line, we do have some other calculation, we have some other techniques to identify the best fit line, but the idea is in the case of regression to identify the best fit line. Come to the next slide. So as I said, in the simple linear regression, the equation could be like this: y is equal to a plus bx plus u, as I said earlier, where a is your, b is treating as like a slope, like a, the coefficient for the slope, like in the straight line, if we are having a relationship x and y, and then the y could be x having some slope. So this slope coefficient is being represented by this b. A is the, I must say, the intercept or the adjustment in the regression, and u is some error term, as I said earlier. In the case of single or simple regression, this is sufficient. But if I do have multiple input factors or multiple independent variables, then the equation could be in this form. The a is going to be constant in the same way and the u is going to be have in the same way. But instead of this x, now I am having x1, x2, x3, x up to xn. It would be the 4, b4, x4 up to bn, xn. So likewise for every x, I can have a different association. b1 means the slope variable for the x1 for the variable x, the slope variable of b2 for the x2, likewise this. So this is called as the multivariate regression or multivariate analysis, multivariate linear regression, right? So in the case of non-linear, simply rather than a straight line, we do have a curve. This curve is not only this curve, the shape of the curve is not limited to this. The shape of curve could be like this. Like if we do have the x and y in this form, the curve could be like this, the bell-shaped polynomial. It could be like this, the high variance. It could be like this, like a parabola. It could be like this. So there are multiple shapes and multiple kind of the curve possible. All these comes under a class of non-linear regression, sometimes called as the polynomial regression. So all these points are for choosing the best fit line. So for choosing the best fit line, I need to calculate a cost function. Cost function is nothing else but actually the difference. Means if I am going to predict something and that value is suppose x1, the prediction is done in the form of x1 and the actual value is x2. So there might be a minor gap between the actual value and the predicted value. So this gap is called as the residual. So the cost function is the total of these errors done by the models. So this overall the calculation, the cost function, or I must say that these residuals, the combination of these residuals or the sum of these residuals must be the very minimal. So there, if there are multiple lines we have for the same regression model, if I have these multiple lines, so on which line I do have a minimum cost function. So I would suppose this is the line where the cost function is minimum. So I'm going to choose it as a best fit line. So in the latest models already we have figured out a number of functions, predefined functions we have, predefined libraries we have if we are going to use the Python. So all they do all these tasks on their own. They are well trained for doing all these calculations. So what they are doing actually, they are drawing the multiple lines and they are calculating the cost function of each line, and the line which is having the least cost value, that is going to be chosen as the best fit line. So on the basis of that line, we are going to make some further regressions or further prediction on new query data or the new user data. So it was all about the regression modeling. Now we are going to proceed with the Bayesian modeling. So Bayesian modeling is associated with Bayesian networks. Likewise, in the regression modeling, we were drawing some plots where we are having some a relationship being plot among the data points presented in the data space, and that representation of the relationship is being plotted in some curves, maybe some line or maybe some curves, parabolic curves. But in the case of Bayesian modeling, we do have some Bayesian network. Bayesian network is something like tree kind of the function where we do have some nodes and have some edges likewise. So typically we do use some Bayesian networks for Bayesian modeling, that is based on again the Bayesian theorem. But if I need the backbone is the probability. As I said earlier also, the Bayesian modeling is a probabilistic model where we do calculate the probabilities. We need to figure out the probabilities or happening the events, and on the basis of we are going to predict what could be the probability of happening this on the basis of the previous training data, right? So just to understand the probabilities and just to understand the Bayesian functionality, just start with the random variables. In the case of probability, there used to be some random variable, or we can call the random variable when we are having a variable which is having some possible values. Maybe like in the case of coin, we do have either 0 or 1, or I can say the head and tail. So we can represent head as a 0 and tail as a 1. So possible values are the 0 and 1, and these are the random events, which means if I am going to flick a coin, there could be a heads or there could be a tails. So the possible values could be the 0 and 1, which is totally random. There is no dependency on any other thing. Likewise, if I can have the example of this dice. This dice can have the 6 possible values, 1, 2, 3, 4, 5, 6, and these are totally random, which can be occurred in any way. So kind of the things is called as the random variable or the random values, or maybe the random events. But we are interested in probability when there are two events, when there are two conditions. On that basis, we are going to have a whole scenario. For example, in any game, if I am having the two dice, dice 1 and the dice 2, so the final I must say the final movement on the board is going to have the value obtained by the D1 and the obtained by the D2, and that would be the outcome. On that basis, I'm going to be move my dice in the board. So this is called as the joint probability when this outcome is dependent on the outcome of individually this and individually of this event, right? So in that case, in the scenario, for example, I am playing a board game, and where I need to move my dice, I need to move my player with some values, and these values must be the combination of these two dice, the sum of the values of obtained from these two dices, dice 1 and the dice 2. So suppose dice 1 obtained the value 4 and dice 2 obtained the value 3. So total is going to be 7. So on the value of this 7, I'm going to move my player to the 7th position in the board. So this is joint probability. If you see, there is no dependency that what is the outcome of this. If its outcome is 4 and its outcome is 3, or its outcome is 5, or its outcome is 1, nothing is going to be happen, or nothing is going to be dependent on this dice calculation. Simply, I believe you got it. Means it is a typical joint probability. There is no dependency. Like if I see the event 1 which I am having on the dice 1, and event 2 which I am having on dice 2, then there is no dependency of event 2 on event 1 or event 1 on event 2. No dependency. Both events can happen individually, and the result of these events can be combined to form the final outcome. So kind of the scenario is called as the joint probability. But we have some conditional probabilities as well, where if we are having suppose two dice 1 and the dice 2, this is suppose event 1 and this is the event of this can be called as the event 2, and final outcome is something else. So what I am expecting as the final outcome, for that the dependency is important. Means if E1 is happening something, then its value would be dependent on the E2, the functioning of the E2. For example, I need total as a 7. I need a total 7 of these dice just to be as a winner. In this current, I must say that in current chance, I could be a winner, my player could be a winner if I got the 7 out of these dices. So if I played the dice 1 and I got the value 5, right? So now it is important to obtain exactly 2 from this event 2. Now having another example, if in the dice 1 I am got just a 3, value 3 from the dice 1, then for completing the 7 I need a 4 from this event 2. So the event 2 is dependent on the outcome of this event. In this case, if I need this 7 as an outcome, I believe now you got this. So this kind of the scenario is called as the conditional probability, when the outcome of another event is dependent on its previous event. This can be represented like this: probability of having B when already A has been happened. I must say the probability in this case, the probability of E2 when the event already has been done. So this can be calculated as P of A union probability of A and B when both are happening, and I must say it can be the joint probability and the probability of A, right? So this can be calculated, kind of the conditional probability can be handled using the Bayesian modeling and the Bayesian, specifically Bayesian theorem. All these can be done through some Bayesian theorem. So Bayesian modeling and the Bayesian networking or Bayesian diagrams, Bayesian structures are based on this. The backbone is again the Bayesian theorem. What Bayesian theorem says? It says if I need to calculate the probability or the conditional probability A and B, and means I need to calculate the probability of A when already B is true, then it can be calculated using this: the probability of B when already A is true into the multiply by the probability of A upon the probability of B, where the probability A and B are the probabilities of observing A and B without regard of each other, like in the example of dice D1, D2. So for happening the D1 and D2 is independent, so what could be the probability of D1 and D2 for a particular instance? And PAB is a conditional probability which the probability of observing event A, the first one of A when B is, another one is true, and PB is just opposite of this, when the probability of B when A is true. So this is a typical Bayesian theorem. Using this theorem exactly we need to make some modeling, that is Bayesian modeling. The same thing is rewritten as, but too important is just to understand the PAB is also called as the posterior probability, means the posterior probability after being an event which is already has been happening, the probability of hypothesis A on the observed event B when B already has been done. And PBA is the likelihood probability, which the evidence sometimes is called as the evidence probability of the evidence, given that the probability of a hypothesis is true. And these PA is called as the prior probability, because we are going to have the posterior calculation of A, so it is a prior probability without any condition, and this is the posterior probability when V must be the true. And PB is the marginal probability or probability of evidence. The same thing explained using this figure again. So using all these things collectively, we can draw some Bayesian networks. So I am having a scenario, I am having an example. So first I need to figure out some means events, or I must say that some actors, some event. What are the main events? So I can put these events as these circles, or I must say the nodes, which are the events. And these arrows are representing the association, or I must say the dependencies. Which event is dependent on which, or which event is dependent on which event, and what are their sequences of their occurrence. So Bayesian network, once I form the Bayesian network, then I need to calculate the individual probabilities. If I say like this, so I need to calculate these individual probabilities of PA and PBs and some PBA. Then I can reference or inference that model for some PAB. So first I need to draw this Bayesian network out of my given problems. Just first we understand what is Bayesian network. Bayesian network is a probabilistic graphical mode that represents a set of random variables and their conditions. So we are calling them random variables. As I said, the individual events, regardless of their sequence or regardless of another event, individually events can be called as the random variables. So all the random variables can be represented using some circles, or I can say them event as well. Then their conditional dependency via the directed acyclic graph, and their dependencies, as I said, the arrows are representing the dependencies, means it means the random variable 2 or the event 2 is dependent on the occurrence of 1. The outcome of 1 is going to influence the functioning of event 2. The outcome of 1 is going to influence the functioning of event 3 as well. So this is called the Bayesian network, sometimes called as the DAG as well, direct acyclic graph. Acyclic because it is not going to come again to the 0 anytime, because finally we are going to obtain an event which is the final event, or sometimes we can have some outcome as well from this diagram. So just have an example just to understand it. The nodes representing the random variables and the edges are representing causal relationship. Having an example, we are having a random variable bad weather, and another example and another variable is traffic jam, or I can say it, I am having a condition or event where the bad weather could be the bad and the traffic jam. So this is represented using a Bayesian network. I am having a traffic jam whenever there is a bad weather. If there is a bad weather, I am having a traffic jam, right? So what is it showing? Whenever there is a bad weather, there are high chances there would be a traffic jam. But it is not saying like this. If there is a traffic jam, then the weather would be the bad. No. Or I must say, the traffic jam is not causing the bad weather, but what? Bad weather is causing the traffic jam, right? Bad weather is causing traffic jam, but this diagram is not representing what? Traffic jam is causing bad weather. So the condition of this or the outcome of this is influencing this event. This event is not influencing so much this condition, right? So what I can have the inference, given that the presence of traffic jam is a possible, like if I am having this traffic jam, then what I can inference from this, I can calculate them, then there it is possible to estimate the probability of bad weather, because generally if I am having a traffic jam which is dependent on wet weather, so there are high chances that bad weather caused this, so we can calculate the probability of this. So kind of the examples can be solved, or kind of the problems can be analyzed using the Bayesian networking. This is again the same thing. Another example, very standard example, alarm example, very popular example for Bayesian network. So likewise, it is having some nodes, some events, and their association with each other. And we do have some, likewise I said in this. So what we need to calculate, we need to find out these individual like PAs, PBs and PBs. If I do have the stack of all this, I can calculate or inference this PAB. So what I did in this, we just have this individual probabilities and the PBAs we are having with us. So in this setup, we can calculate any, we can solve any query on the basis of a Bayesian network, or I may say the dependent events like PAB, where PBA and the PAB are individually has been given with us. So for an example, like this, PJ, PMA, all these are given like this in this example. So what we can query, what is the probability of burglary given when John calls and Mary calls? Means John called and the Mary called, both called. What is the probability of having, like they called when there is a burglary? If we do understand, means what it is saying, alarm is ringing when there is a burglary or there is an earthquake. So what are the chances of having the burglary is this, what are the chances of earthquake are these, and alarm when burglary and earthquake both are there, the chances of alarm this, when only burglary is there, the chances of alarm this, when only earthquake is there, the chances of alarm is this. So this is the given the whole scenario. And whenever there is an alarm, the John and the Mary, which are the neighbors of mine, they can call me and update me, so your alarm is ringing. So the question is, what I got a call from the John and I got the call from the Mary as well. So what are the chances? What are the probability? There would be a burglary, right? So the equation or the solution I need to find out is PB when J and M are given. So I can apply the simply Bayesian theorem just to solve this problem. So this is all about the Bayesian networking. You can solve any kind of the probabilistic problems using these these models based on the Bayesian network, and the standard application of the regression modeling can be used for some standard regression problems. So for today's, it's all about. Thank you.